Hello students. Today we are going to discuss about complex numbers. So when we talk about complex numbers, so complex number will be generally represented by Z. Now when I write a complex number, I can write a complex number in this form: Z is equals to A plus iota B. Now over this iota we have already discussed. Value of iota is equals to root over minus 1. So this is an imaginary number, and over here there are two parts of this complex number. One is called the real part. So real part of the complex number is A, and imaginary part of this complex number, is written by IMZ. So imaginary part of complex number is given by B. So real part of the complex number is A and imaginary part of the complex number is B. Now, see, if I have to find out the conjugate of this complex number, if I have to find out the conjugate is generally represented by Z bar. At times they represent it by Z dash also. So if this is Z and I have to find out conjugate of this complex number, so I'll simply write A minus iota B. Real part and imaginary part will remain same. Only the sign between the real part and imaginary part over here will be changed. Now, if I have to find out modulus of a complex number, it is represented by modulus of a complex number, modulus of Z, and the formula for that is modulus of Z is equals to A square plus B square. Now, so I'll just repeat again. A complex number will be given by A plus iota B. A is the real part. Imaginary part will be given by B. Conjugate of a complex number is Z bar. It's represented by Z bar, and it can be A minus iota B. And magnitude or modulus, of this complex number will be given by root over real square of real part. I'll just write a generalized formula: real part of Z whole square plus imaginary part of Z whole square. This is how we represent modulus of a complex number. So I'll just take one example. Say I have a complex number Z is equals to 2 minus 3 iota. Sometimes you write it 2 minus iota 3 as well, no problem. So over here, if I want to write real part of Z, that is 2. If I write imaginary part of Z, that is going to be minus 3. Remember, while writing imaginary part of Z, we do not include this iota. Now, if I have to find out Z bar will be 2 plus 3 iota. If I have to find out modulus of Z, answer is going to be square of imaginary part, that is 4. Square of real part is in fact 4, and square of imaginary part is square of minus 3. So 4 and 9, that is going to be 13. So this is how we find out conjugate and modulus of any complex number. Now what we'll do, we'll just go to the next page. Okay. Now after knowing about what is the real part, what is the imaginary part, what is modulus, and what is conjugate of any complex number, now we'll come to the most important thing, and that is how to find out argument of a complex number. Now when I say about argument, say if I have Z is equals to A plus iota B as my complex number, then argument of Z will be given by tan inverse modulus B over A. This is how we find out, and this can be written in the generalized form, and that is imaginary part of Z divided by real part of Z. This is how we find out argument of Z. But this is not it. Like, argument of any complex number depends on the quadrant. So this I will just write argument of Z, I'll write it as theta, and argument of z depends on that this complex number is falling in which quadrant. If it is falling in first quadrant, there's no problem, fine, I can use theta as it is. But if it is going to fall in the second quadrant, the formula to find out argument of z, I am going to use pi minus theta. If it is falling in the third quadrant, I will use pi plus theta. If it is falling in the fourth quadrant, I am going to use 2 pi minus theta. This is not just one formula. There is another formula which we use to find out. So that is theta, pi minus theta. The next is going to be theta minus pi and minus theta. So we can use this formula or this formula. If we have to keep theta between minus pi and plus pi, then we are not going to use this formula. We'll use this formula. This is called principal value of the argument of a complex number. So whenever I have to find out argument of any complex number, first I am going to find out theta. That is tan inverse modulus of imaginary part of z divided by real part of z. Then I'll identify that in which quadrant my complex number is falling, and then accordingly I'll use this formula and find out. So this is a bit tricky, so I'm going to take an example. So what I'll do, I'll take z is equals to 2 minus 3 iota, which I've used earlier also. First thing I'll do will be, I will be find out theta. So theta is tan inverse modulus of imaginary part divided by real part. So my answer is going to be tan inverse 3 by 2. But this is not it. What I have to do, I have to check that 2 minus iota is going to fall in which quadrant. So for that, what I'll do, I'm going to write this complex number in form of x and y ordered pair. So 2 is my real part and minus 3 is my imaginary part. If I want to check that this point is falling in which quadrant, so my x is positive, but y is negative. So I am going to fall somewhere in the fourth quadrant. Now what I'll do, I'll check the formula for the fourth quadrant. So I can use this or I can use this. So I will write argument of this particular complex number will be given by 2 pi minus theta, and my theta over here is 2 pi minus tan inverse 3 by 2. So this will be my answer, or I can just write down minus tan inverse 3 by 2 as well. So this is how we find out argument of any complex number. Now what I'll do, I will take a few more examples and then I will try and clear how to find out real part, imaginary part, conjugate, modulus and argument of it. Okay, so now I will take another example. Say z is equals to minus 1 plus iota. Another one is z is equals to 1 minus iota. And the third one is z is equals to 1 plus iota. So I can just write this as z1, I can write this as z2, and this I can write as z3. So what I'll do, I will just find out first the real part, then I will write imaginary part, then I am going to write its modulus, then I will find out its conjugate. I will try and find out the conjugate, and at the end I will show working how to find out its argument. How to find out the argument. So I'll just delete this thing, and now I'm going to find out argument of it. So I'll just write down argument. So if I want to write down the real part, the real part is minus 1 over here. Real part for this is 1, and for this also real part is 1. If I write the imaginary part, so it's 1 over here, it's minus 1 over here, and plus 1 over here. If I take the modulus, so that is root over minus 1 square, that is 1, plus 1, so it will be root 2. Same goes for this, root 2, and same for this, that will be root 2. If I have to find out conjugate of this, so z1 bar, which will be minus 1 minus iota. Conjugate of z2 is going to be 1 plus iota. Conjugate of z3 is going to be 1 minus iota. What I have to do is, I just have to change whatever sign given over here. If this is plus, I'll write minus. If this is minus, I'm going to write plus. Now the most important thing is argument. So what I'll do, first I will find out theta. theta will be tan inverse real imaginary part, that is 1 over minus 1. So that is going to be tan inverse 1, which is pi by 4. Now what I'll do, I'll just draw and I will just try and check that this is lying in the which quadrant. So if I write in the coordinate form, so this is minus 1 plus 1, x is negative, and y is positive. So this is lying in the second quadrant. If I check for this, x is positive and y is negative, this will lie in the fourth quadrant. And if I check for this one, so this is going to lie in the first quadrant. In first quadrant, theta will remain theta. In the second quadrant, I will write pi minus theta. In the third quadrant, I will write pi plus theta. And fourth, I am going to write 2 pi minus theta. So for this one, as this is lying in the second quadrant, so I am going to use this formula. So my argument of z over here will be pi minus theta, and the value of theta is pi by 4. So my answer is 3 pi by 4. If I check for this is lying in the fourth quadrant. In fourth quadrant, formula is 2 pi minus theta. So for this, argument of z will be 2 pi minus pi by 4. So my answer is going to be 7 pi by 4. Or if I use the other formula, I can just write minus pi by 4 as well. Theta is coming from here. And over here, this is the first quadrant. So my theta, it will be same as argument of z. And the answer is pi by 4. So this is how we find out real part, imaginary part, modulus, conjugate, and argument.